Alright, so this is my kayak, which I recently welded, and which is the topic of this video. I think it's important that I mention before we get started two things. One, I don't know what I'm doing. Have no training in welding of any sort, and specifically no training in plastic welding. Although I did spend quite a while, which we'll see here in a second, trying to figure out how best to do this. And then two, I just welded this yesterday or the day before, and so I haven't tried it. I haven't used it. Now, I don't know how this will hold up. If it doesn't hold up well, I will post a follow-up video on what happened and why and how I repaired that. So without further ado. All right, so I've been experimenting and practicing for about 2 days here. I figure I've probably done 40 different welds. Used soldering iron, used a heat torch. This is a tiny little heat torch. It just shoots heat, no flame. Also used a full-size heat gun. Done mesh and no mesh. I've done with HDPE strips, and then also without strips, just using the material that's already there. And then I also have even, these here were me heating the HDPE in the oven to about 290 degrees, and then heating in this case, the surrogate kayak with the heat gun, and then binding the two together as well. So I've done a fair amount of experimenting here. I guess of some note, you'll notice that all of these are broken. And that's because I welded all of them and then broke them on purpose to see how they stood up to some stressors. And there's some interesting findings, and we'll talk about that later. And I think something that is interesting to note here is it doesn't generally break along the welded crack, but instead just adjacent to that, where the heated to melting point HDPE meets the HDPE that was not heated. All right, so two more important points, kind of to frame this whole discussion. This is the weld that I completed, but importantly, one, scuppers are very fragile, relatively fragile portion of the kayak in comparison to the rest of the kayak. And then two, heating HDPE makes it brittle. And we're going to discuss both of those. All right, so this is just a regular old piece of HDPE cut off from that bucket. And then this is a similar piece that I put in the oven at 290 degrees. I found that 275 degrees doesn't melt it, and 290 does. And so then I let it cool off. Now let's see, I'm going to do a little test here, one-handed test. This is the HDPE that has not been heated. All right, and then this is the HDPE that has been heated. All right, so this is two pieces of HDPE from this bucket here that I welded together. I used my mini heat gun, heated up both ends, and then once they were both melty, push them into each other. And now the reason I'm showing you this is I haven't done this, but my guess is that when we try to break this, it will not break at the joint, but instead in some of that brittle post-heating HDPE. Let's see what happens. All right. So yeah, the joint is fine. Doesn't come apart at all. But it broke in the brittle area, kind of where it starts, the heated stuff starts to meet the unheated material. And then I'm kind of hoping to be able to show here the thickness of the HDPE on the surface of the boat. And then we're going to compare that to the thickness in the scupper. It's thinner even up farther you get, but the difference in the thickness of the plastic, the HDPE, in the scupper hole versus in other areas of the kayak. All right, so here's a new crack in quoticulations. And I'm going to use the method that I believe is, for my purposes, is likely to be the most durable. And I'm going to show you kind of the end result of that here in a second, and then describe what I've done. So you can see what I've done here is I just pushed the soldering iron kind of perpendicular to the axis of the line, the crack, excuse me, you know, sequentially at regular intervals along the entire length of that line. So this is not the same weld, but it's the same process. And you can see here what I've done is pulled the material that was displaced by the transverse markings left by the soldering iron back into those markings such that they're largely obscured and watertight. All right, so this here is Peerless brand lint screen for wash tubs, apparently. It's stainless steel. It's sort of like chainmail almost, although very fine. If you put a flame on this, it turns red immediately. And then I'm going to be using this Schneider, which is the Harbor Freight heat gun / soldering iron. It's butane fueled portable soldering iron / heat gun. All right, so no tripod, so I did this, and now we'll talk about it. Here's that tool. It's lit, shooting some heat out the end, and I've used it to tack down that stainless steel lint filter. So I'll show you a little bit of how I was doing that. Now, what I'm going to do is, as best as possible, try to heat the top layer, just the top layer of this HDPE here, and then so that the top layer becomes pliable, melted, essentially. And then I'm going to roll this fabric into the top layer of melted HDPE. So in summary, what I've done here is I sealed the crack with somewhat superficial, maybe a third to half depth of the actual HDPE penetration with the soldering iron, excuse me. And then over the surface of that, I've impregnated the HDPE with this wire. So the soldering iron portion was to seal the crack, and make it approximate the edges, seal the edges together, and make this watertight. And then, but the not really to make it strong. I was intentionally trying to use as little heat and melt as little HDPE as possible. Then getting the strength from the wire mesh, which I impregnated into the HDPE here. So, can you break this? Absolutely. Where will it break? It'll break where it got really hot and changed the properties of the HDPE. But it's more flexible than the other methods, and it's pretty strong because of the stainless steel mesh. And if you want, like I said, you can cover this up. What I'm going to do is put this part on the inside of the kayak, and then I'll do the other part. Here's one that I did crack, but because I've been breaking all of them. But here's one that I spent a little time on, and it'll look like this on the outside. All right, so here's what I did. This is the outside of the kayak and the inside of the scupper hole. So is it strong? I doubt it. Is it waterproof? Pretty sure, yeah. We'll test it. Then we'll put the strength on the inside with additional welding and the stainless mesh. So this is the end result from the inside. So again, not an expert. This is how I personally chose to solve those two issues. That is, a relatively thin scupper material and notably brittle heated HDPE material. So I chose to try to heat as little as possible, or at least superficially. Now, of course, another solution would be to just glob a bunch of HDPE on there and make it so hard that it didn't matter that it was brittle. And I may end up there, but for now, we're going to try this with the strength coming from the mesh and the water tightness coming from the superficial welding. And if this doesn't work out, I'll post a follow-up video and let you know what happened and how I fixed it.